Any rational number can be written in decimal form. The decimal expansion of a rational number is either terminating or non-terminating and repeating. The theorem states that if A is a rational number whose decimal expansion terminates, then A can be expressed in the form x by y, where x and y are co-prime, y is of the form 2 to the power r, 5 to the power s, with r and s being non-negative integers. Let's consider the example of 0.5, which is a terminating decimal. In the form x by y, it calculates to 1 divided by the product of 2 to the power 1 and 5 to the power 0. Here is another example, the number 2.6. It can also be expressed with the product of the powers of 2 and 5 in the denominator. The converse of the theorem we just learnt also holds true, which states that a rational number A is equal to x by y, where x and y are co-prime integers. Y is of the form 2 to the power r, 5 to the power s, with r and s being non-negative integers, can be expressed as a decimal expansion which terminates. Let's consider a rational number 17 divided by 50, which is in the form x by y, and 17 and 50 are co-primes. Here, the denominator 50 can be expressed as the product of 2 to the power 1 and 5 to the power 2. In decimal form, 17 divided by 50 is equal to 0.34, which is a terminating decimal. Here is another example, the rational number 3 upon 2, which becomes the terminating decimal 1.5. The reverse of the theorem on terminating decimals states that the decimal expansion of a rational number A is equal to x by y, where x and y are co-prime integers, y is not of the form 2 to the power r, 5 to the power s, with r and s being non-negative integers, will be non-terminating and repeating. Let's consider a rational number 13 divided by 30, which is in the form x by y, and 13 and 30 are co-primes. Here, the denominator can be written as the product of 3, 2 to the power 1 and 5 to the power 1, that is, not as the product of powers of 2 and 5 only. In decimal form, 13 by 30 calculates to 0.43333 and so on, which is a non-terminating, repeating decimal. Here is another example, the number 11 by 7. Let's understand, without dividing, how we can find whether a rational number has a terminating decimal expansion or a non-terminating and repeating decimal expansion. The number 29 by 343 is in its simplest form and can be expressed as 29 divided by 7 to the power 3. Also, 343 is equal to 7 to the power 3 is not in the 2 to the power r into 5 to the power s form. So, 29 by 343 is a non-terminating and repeating decimal. Tap the buttons to understand this better with more examples.
Enter a rational number to find out if its decimal expansion is a terminating one or a non-terminating and repeating one.
Fill in the blanks with the correct values. Fill in the blanks with the correct values. Fill in the blanks with the correct values. Choose the correct options. Choose the correct option. Let's summarize what we have learnt in this topic.